Assalamu alaikum. Welcome to lecture 15 of data mining. So we are done with half of the lectures in this course. So we are in the second half now, lectures 15 to 28. So before we stopped for the midterm exam, we were talking about decision tree learning. Uh, so we will discuss a few more concepts, ideas from decision tree learning, and then talk about random forest. And then after that, we will start with cluster analysis or clustering, which is the next major task we will be covering in this course. Uh, so, so that is basically the agenda for today. So we do have a quiz at the end of class today. This would be your fifth quiz. Uh, so so we'll be starting our routine for quizzes again once after the mid, which was held last week. All right. So are there any questions before I get started? So in the last lecture before we stopped for the midterm exam, we were talking about decision tree learning. So we had talked about classification trees as well as regression trees. And we mentioned that uh, the process of building a decision tree is greedy and it's divide and conquer by repeating a selection process where we decide which attribute to select as the splitting attribute at a particular node in a decision tree. So at the we start with the simplest tree, which just consists of one node, and we split the data using the decision based on that one node, the attribute and its values based on that one node, and then we repeat the process after the edge of that one node until we reach a leaf node. The leaf node is then labeled with the appropriate class or the appropriate value if it is a regression problem. Uh, so we basically stop for classification if we have exhausted all the attributes from the root to the leaf node, meaning that we have used all the attributes in the data set, or we stop if uh, the leaf node or the data that filters to that particular node becomes pure, meaning that all the data falling into a particular node have the same class or same label. So, or of course, if your data set is complex, your problem is complex, you wouldn't be able to achieve that. You will stop when the entropy of the data set being filtered to a particular node is less than some small value, right? So we talked about uh, a number of selection criterion or measures. We talked about information gain. We talked about information gain that was based on entropy. And we also talked about information gain that was based on Gini. We also talked about gain ratio. So these were some of the measures that we talked about or the selection criterion that we talked about. So we had discussed constructing a decision tree, either classification or regression tree, for data sets that are described by categorical categorical attributes only. So meaning that the attributes, let's say gender has only two possible values, M and F. Job rank, it has values like assistant manager, senior manager, and manager. So the values were discrete. Uh, so now let's briefly discuss what happens if your data set is described by attributes that are continuous. Let's say you have a problem where you have income as an attribute, and then you have a class, just a simple example that I'm taking. Maybe we have two attributes, income and uh, let me take another numeric attribute, let's say age and then class. Okay. So, so income is continuous in general. Age is also a continuous. It's an integer. And then we have class. Class could be anything that is relevant for your application. So let me just take the case of income and class and write some values, income and class. So let's say we have an income of 50, we have income of 80, we have income of 100, we have income of 200. I've sorted these incomes. Let's say income of 250. Okay. So let's say the class, let's talk about, let's say even gender. The class might be determining, or let me say the class is the role of the employee, like assistant manager or senior manager. So 50 is assistant manager. So this is also AM. Let's say this is SM. So 200, let's say this is also AM. And let's say this is SM. Okay, this is one attribute in the data set. I'm just trying to explain how we can use such an attribute in a decision tree. Okay. So first of all, we will have to sort the continuous attribute, and along with that sorting, ascending order, we will be sorting the corresponding class label. In this case, the class label is the job rank. Okay. So we have sorted it. So in when you had an attribute that was categorical, we already had our splits. So we split at each value of that attribute. But when the attribute is continuous, you cannot split at each value. Okay? You don't have those fixed values on which you can split, because now the income is not discrete, it's continuous from 50 to over 250. Okay? So we will have to test for various splitting options, various splits, and usually the splits are binary for continuous. So the options are, we look at the sorted list of the classes and see whenever there's a change in the class label, we consider that to be a potential uh, splitting threshold. Okay? So 50 is assistant manager, 80 is also assistant manager, 100 is senior manager. So there's a change in label from AM to SM between 80 and 100. Okay? So one splitting criteria and threshold could be income is, let's say, greater than equal to, let's say, the value between 80 and 100, which is 90. Okay? So if the value is greater than equal to 90, we go to one split. If it is less, we go to the other split. So this is one option. So we will consider all options. Let's say I call this option A. So 100 SM, 200, then again AM. So there is a change from SM to AM again. So this is another candidate for our threshold. Okay, and then from 200 to 250, there's again a change. So between these two, we have another option. So B, so income greater than equal to, let's say, 150. Okay, and C, income is greater than equal to 225. So we now have three options for splitting for just one attribute. वरना पहले जब categorical attribute होता था एक ही split की option होती थी according to the values of that attribute. ठीक है? So now for one attribute we have three options. अब इनमें से कौन सा select करना है? Again we will go ahead and use and compute information gain. So I will compute information gain. So information gain for A, ठीक है. I will compute information gain for B. I will compute information gain for C. और जिसका इंफॉर्मेशन सबसे ज़्यादा है, गेन सबसे ज़्यादा है, आई विल सेलेक्ट इट एज द स्प्लिटिंग criteria at a particular node. But this was for just one attribute. So let's say we have another attribute, age attribute भी है, ठीक है ना. इसी तरह age attribute के भी कुछ options होंगे. I have not written the numbers, but let me write it here. D, option D है, age is greater than or equal to let's say 10. Option E है, age is greater than or equal to let's say 40. दो options थी. So actually your final decision would be IG A, IG B, IG C, IG D and IG E. पांच आपके ऑप्शंस हैं. इंफॉर्मेशन गेन निकालेंगे और उसमें से देखेंगे किसका सबसे ज्यादा है. सो लेट्स से IG B सिलेक्ट हो जाता है. जस्ट एन एग्जांपल, अज्यूम B इज सिलेक्टेड. सो इसका मतलब है कि या नोड में जो कंडीशन लगेगी वो क्या लगेगी. बी वाला क्या था, इनकम is greater than or equal to 150. So you will be splitting using condition income greater than or equal to 150. If it is yes, you go to one direction. If it is no, you go to the other direction. ठीक है, इस तरह ये आपका split होगा. As I said, for a continuous attribute, there will be only two edges or two branches from a node. Categorical attribute में कितनी branches होती थी, जितने उसके values होती थी. But for continuous attribute there will be only two branches, but you will have to decide कि उसका threshold क्या है splitting का, और वो decision information gain से ही निकलता है. So just to repeat, if you have a continuous attribute like income, you sort that attribute you sort income, and of course your class would also be sorted according to that sorting of income. And then you take as candidate thresholds all values whenever all values of income at which there's a change in label of the class. So in our case, there was a change in label. For 80 it was AM, for 100 it was SM. ठीक है, तो हमने उसके दरमियान में एक थ्रेशोल्ड ले लिया, लेट्स से 90. तो वी सेड दैट वी स्प्लिट आवर डेटा यूजिंग दिस थ्रेशोल्ड. उससे कम होगा तो एक पार्टीशन होगी, उससे ज़्यादा होगा दूसरा पार्टीशन होगा. So this was one option. So similarly, 150 was another option, and income 225 was another option. So for one attribute, we had three options. But let's say आपके पास 5-10 और attributes भी हैं, तो सारे attributes के आपके पास सारे options इकट्ठे करके जिसका सबसे ज़्यादा IG आ रहा है वो आपने choose करना है at a given node. So by the way, ये जो process मैंने discuss किया है, where you are splitting a continuous attribute using the class label, this is exactly same as the supervised discretization approach. ठीक है, remember we discussed discretization in chapter 2, entropy based discretization. This is what you do in entropy based discretization. It's a top down approach, it's a splitting approach. So हमारा ऊपर वाले केस में क्या है, let's say if you select B वाला income greater than equal to 150, इसका मतलब है कि जो इंटरवल बिफोर 150 है वो एक डिस्क्रीट एक बेसिकली इंटरवल है, और 150 के बाद दूसरा इंटरवल है. ठीक है, एंड ऑफ कोर्स यू कैन रिपीट दिस एज यू मूव डाउन इन द डिसीजन ट्री. ठीक है, so this is the difference in processing if you have a data set which has continuous or numeric attributes. ठीक है, so previously we had discussed data set that had discrete or categorical attributes. In that case, for one attribute, there was one option only. Uh, but of course, you had to compute IG for all attributes and select the attribute that had the maximum IG. In this case, for a single attribute, you may have multiple options. And if you have multiple attributes, the total number of options may be quite high. और उन सारों में से आपने एक select करना है at any given point in time. The rest of the algorithms proceed in the same fashion. So once you have done a split, you repeat the process at the next uh, partition, next split, until you reach a leaf node, ठीक है? Or until you have reached the stopping criteria. One other comment here, remember when we discussed discrete attributes dataset or categorical attribute dataset, we said that if you used one attribute at a particular node, you cannot use that attribute later on. But in the case of continuous attribute, you can have a tree like this. So you have income greater than equal to 150. आपके पास ये path जा रहा है, yes. So अब ये yes वाला path क्या है? These are all data that has income greater than 150. अब इसके आगे you may have another split, income greater than let's say 200. एक और split आ सकता है. उसी path में you can have the same attribute but at a different threshold. तो ये हो सकता है. While when we were discussing categorical attributes, income could not appear twice in a particular path. एक दफा जब use हो गया तो वो सारे उसके options exhaust हो गए. वो फिर से नहीं use हो सकता. While in this case it can be used because उसका जो partition उस side पे है उसको further भी आप partition कर सकते हैं. ठीक है? Let's say you reach the leaf node here. So it is perfectly possible. Of course, all these decisions would be made based on your selection criteria. Let's say using the information gain uh, measure. All right, so we have discussed decision trees, classification trees, and regression trees, which we have discussed building decision trees for categorical data set. We have also now discussed building decision trees for numeric attributes. Last time we also talked about overfitting, which is a concept from machine learning. Overfitting occurs when the model gives you good performance on the training data set, but gives you poor performance on the test data set. The model has fitted the training data or overfitted the training data. So that is in general undesirable because we want our models to perform well on new examples, those examples that were not already in the training data set. So to fix for to control for overfitting, we use the process of pruning. We discussed this last time briefly, so I'm just repeating it here. So pruning basically means that you simplify the decision tree. You remove nodes or edges from the decision tree. In general, the complexity of a decision tree is defined by the depth and the number of nodes in it. So if you have two decision trees, if one tree has 100 nodes, decision nodes, and the other has, let's say, 300 decision nodes, the 300 decision node tree is more complex. And from machine learning theory, we know that the 300 node decision tree is more likely to overfit because it's a complex model, it's more expressive. So to make it simpler, we'll have to remove nodes. So that is called pruning. So pruning में जैसे last time मैंने कहा था कि we talked about there are two basic uh, approaches. Basically, I would say how to control overfitting. So there are two approaches. One is early stopping, and the second is pruning. Early stopping means that you stop growing the tree, and the second is uh, pruning, which is you after you build the tree, you remove nodes or you simplify the tree. And in this case, you can have pre-pruning, meaning that sorry, not pre-pruning, sub-tree pruning, and then you have rule pruning. So So these are two ways of doing pruning. Rules means that you convert the tree into rules and then do the pruning. While sub-tree pruning is आप कोई भी tree का node पकड़ें उसको remove कर दें. ठीक है. So इसकी details में मैं नहीं जाऊंगा. Just refreshing it from the last lecture. Okay. So decision trees are a popular classification. Is a popular classification technique. It gives us good results in many applications. It is also very interpretable, meaning that once you have a tree, you can explain the decision made by a tree very easily to some layman. So maybe let's say आपने tree ये ऊपर हमने जो आ, उसके लिए बनाया था आ, क्या कहते हैं मैनेजर या जॉब रोल के लिए तो यू माइट हैव a rule like this. Let's say income greater than equal to let's say 150 and age is less than equal to 30 implies that uh, basically class is equal to assistant manager. ठीक है ना. दिस इज वन पाथ ऑफ योर ट्री. रूट नोड में एम होगा क्लास लेबल और फिर पहले उसके ऊपर आएगा फिर एज फिर उसके बाद आएगा इनकम. ठीक है एक सेकंड. ठीक है सही है ना. सो ईच पाथ फ्रॉम द लीफ टू द रूट बिकम्स a रूल. अब ये if you have a decision that is AM, you can easily explain to some person why I got an AM because this person is income is this and this person's age is that. So explainability बहुत easy है. बट इसका जो ड्रॉबैक है मेन ड्रॉबैक है डिसीजन ट्रीज का कि इट इज प्रोन टू ओवरफिटिंग. सो यू कैन लर्न इफ योर डेटा सेट इज स्मॉल you can learn even noises and errors in the data. और सिंस ओवरफिटिंग होगी है तो न्यू एग्जांपल्स पे वो पूर परफॉर्मेंस करेगा. ठीक है. उसका जो एक तो तरीका ठीक करने का मैंने बता दिया कि यू डू अर्ली स्टॉपिंग एंड देन डू प्रूनिंग. मे बी अदर अप्रोचेज आर यू use some modified versions of decision tree learning. So we will first discuss some of these ideas. So first one is forest. So tree is one decision tree, forest is multiple decision tree. So this is an ensemble approach. This is a general concept from machine learning. We won't go into the detail here, but essentially it means that आपने decision एक classifier से नहीं करना, multiple classifier से करना है. ठीक है. एक क्लासीफायर जो आपने बना लिया एक ट्री बना लिया उससे नहीं डिसीजन कर रहे आप. बेतहाशा ट्रीज बनाएंगे और सारों को इकट्ठा लेके चलेंगे और डिसीजन सारों को लेके करेंगे फाइनल. So one approach, as I said, is based on forest. Let's discuss what are the ideas here. So forest basically uses what is known as bootstrap aggregation, जिसका short often times लिखा जाता है bagging. ठीक है. Basically B से bootstrap है, एगिंग को एग्रीगेशन से बनाया हुआ इन्होंने. ठीक है बैगिंग. सो bootstrapping basically means multiple sampling. ठीक है. And aggregation, of course, aggregation is based on majority vote classification. Yeah, if it is a classification tree, if it is a regression tree, you simply take the for classification or mean for regression. ठीक है. So let's discuss the idea. So basically, what do we have typically? We have a training set with n examples. ठीक है ना. ट्रेनिंग सेट में क्या होता है ट्रेनिंग एट्रीब्यूट्स भी होते हैं क्लास लेबल भी होती है सुपरवाइज्ड लर्निंग है रिमेंबर. So you have the attributes as well as the class label. So you have n training samples. So you don't build just one tree. जैसे हमने पीछे एल्गोरिथम देखा एक ट्री बनाया. Now you build multiple trees. So you basically do you sample the training set multiple times using simple random sampling with replacement. So बूटस्ट्रैपिंग में विद रिप्लेसमेंट सैम्पलिंग करनी है हमने. ठीक है. So let's say you do create B samples, and usually B is in the hundreds or thousands even. ठीक है. So let's say मैं कहता हूँ B 100 है, तो आपके पास डेटा सेट था जिसमें let's say let me take an example, n is equal to let's say 500 examples हैं, और B let's say मैं कह रहा हूँ 100. So you will resample these 500 examples 100 times, and you will do sampling so that you get a data set of 500. ठीक है. So and you are doing this with replacement. So इसका मतलब थोड़ा बता repeated attributes आ सकते हैं, maybe some थोड़ी some repeated observations आ सकती हैं, examples आ सकती हैं, sometimes कुछ examples miss हो जाएंगी, select नहीं होंगी, but you will have a lot of such samples, 100 of them. So you basically build a decision tree for each sample. So what you will have? You will get basically B decision trees. Okay? So now you don't have just one tree, you have B decision trees. And for building the decision tree, you can follow any approach that we have discussed. You can use information gain for classification trees. So you now build 100 decision trees for the same problem, but built on slightly different data set that are sampled with replacement from the original data set. ठीक है. So अब तो ये मॉडल्स बन गए आपके पास, अब 100 मॉडल्स बन गए, not one. So how do you make future predictions? So predictions या future classifications. So you will get a classification from each tree. So you will get B classifications for each new observation. ठीक है. So what would be the best label? Of course, those B would be 100 classifications. तो आपने सिर्फ एक लेबल लेना है, तो just take the majority vote. ठीक है. So let's say मेरे पास 2 क्लास प्रॉब्लम थी ऊपर AM SM वाली. So let's say मैंने 100 मॉडल्स बनाए, तो मेरे पास for some example, for one particular example, मेरे पास 60 लेबल्स आए AM के, और 40 लेबल्स आए मेरे पास SM के. So majority vote क्या होगा? Would be of course AM. But you might also consider keeping the entire data, because आपके पास अब distribution आ गई है. You know that 0.6 probability से ये confidence से ये AM है, and 0.4 confidence से ये SM है. So you can also keep that as well. But if you want just one label, just take the majority vote. So 60 models were saying AM, 40 models were saying SM, so the best label is AM. So this approach, since this is based on random data set that are sampled with replacement from the original data set, it is able to avoid some of the pitfalls of overfitting. So randomness से कुछ चीजें noise cancel out हो सकती हैं, कुछ मतलब you are not learning one thing exactly thoroughly. Now you have 100 models that are learning different aspects of the model. Or collectively उनका decision would be much better than the decision of one model. ठीक है. So ensemble approach है. So this approach is called the forest, simply the forest. Although random forest भी कहते हैं इसको, but random forest थोड़ा सा से एक step आगे है. So we are going to discuss that next. So random forest क्या चीज है? Although इसमें original forest में भी randomness है, but random forest में वी एड एडिशनल लेवल रैंडमनेस। उसमें बैगिंग थी, पहले वाले में बैगिंग थी, अब इसमें बैगिंग भी है प्लस रैंडम एट्रीब्यूट सिलेक्शन भी है। बैगिंग ऑफ कोर्स ऑब्जर्वेशंस को सिलेक्ट कर रहे हैं, और द सेकंड अप्रोच इज सिलेक्टिंग द attributes. So let's say we have our problem has m attributes. So what we do is, of course, we have the same process. आपके पास b samples होंगे, आपने b दफा मॉडल बनाना है। b इज द नंबर ऑफ सैंपल्स, बैगिंग में आपने सैंपल्स लेने, b सैंपल्स अपने लिए। बट हर सैंपल में जब भी आपको डिसीजन लेना चाह रहे हैं एट एनी नोड, you don't decide over all the m attributes. You only decide over, of course, this is a heuristic, a square root m of the attributes that are randomly selected. ठीक है। So let's say मैं रूट नोड की बात कर रहा हूँ, और let's say मेरे पास m था, let's say 10, ठीक है, और इसका 10 से मैं ओके 10 ही ले लेते हैं, ठीक है। सो इसका स्क्वायर रूट होता है 9 point something, so we round it down, sqrt, the floor of this is equal to 3। इसका मतलब है कि हमने रूट नोड में सिर्फ 3 एट्रीब्यूट्स के बेसिस पे डिसाइड करना है। तो लेट्स से मेरे पास टोटल एट्रीब्यूट्स थे ए बी सी डी टिल वट एवर 10 एट्रीब्यूट्स का लेटर क्या बनेगा, I'm not too sure, ए बी सी डी ई एफ जी एच आई जे, ठीक है ना, टिल जे। So now you will generate a uniform random number and select 3 possible values। लेट्स से पहले आपने सेलेक्ट किया तो लेट्स से सी आ गया, फिर से आपने सेलेक्ट किया तो लेट्स से जे आ गया, और फिर से सेलेक्ट किया तो ए। So now you will only use information gain to select among A, C, and J, not over the entire set at the root node। इसमें से जो भी बेस्ट मिला आपको इंफॉर्मेशन गेन से, वो आपने रूट नोड के लिए ले लिया, and then you move on to the next level। So next level में you will repeat the same, you select randomly from A to J कौन से attributes हैं। Of course you wouldn't be selecting any one of these that has already been used if it is a classification problem, uh, so you will randomly select from the remaining and then you repeat this process। मतलब ये है कि attribute selection में भी आपने randomness डाल दी है, in addition to the randomness that you have done with respect to the data, the examples। The rest of the process remains the same। आपके पास at the end of the day you will get B models। कोई नई क्लासिफिकेशन करनी है, you will get B labels। अब उसमें majority vote आप ले सकते हैं, जिस हमने पहले किया था 60 gave AM, 40 gave SM, तो इसका मतलब AM is the best label or the majority label। ठीक है। So the standard regular forest is an ensemble approach which resamples the data and creates multiple models and then predicts using all those models using majority vote। Random forest does the same thing, plus it also randomly, or you can say, adds a degree of randomness in the attribute selection as well। So it restricts the batch of attributes randomly from which it selects the best attribute। ठीक है। So this approach would then give you your random forest। So random forest actually, in practice, gives you very good results। It's oftentimes very competitive for many applications। Sometimes it will even beat decision trees. It will even beat neural networks। So it's a popular approach and sample-based approach, and it's easy to implement। इसकी further extensions भी हैं। I'll just mention some names here, I won't go into the details। One is called extra random trees or extra trees। which basically stands for extreme random trees. ठीक है? Uh, the difference here is that in this extreme random trees, इसमें जो attribute selection हमने वो square root m से की थी ना, and we got a pool from square root m, और फिर आपने information gain use किया था in uh, in extremely random trees. We basically do not use any selection criterion. Simply select randomly. ठीक है? So we have added even more randomness into the models. But of course, to get good result, you need to have even more models. B would be even larger. So this is the main difference. छोटी मोटी एक दो और differences भी हैं, but I don't want to go into that. This is the main difference. So this is called extra trees or extremely random trees. ठीक है? और एक और further variation है, which involves parametric learning. So far, all trees that we have discussed were purely information theoretic. कोई इसमें ऐसा parameter नहीं था. So these trees are called gradient boosted trees, GBT. ठीक है? So I'm mentioning these names because you will see their implementations in various APIs and libraries. तो आपको पता होना चाहिए कि ये क्या चीज़ें हैं. The gradient boosted trees, uh, the main thing is for each decision node, it's not based on one attribute. It can be based on multiple attributes, not just one attribute. पहले हमने जितना भी डिसीजन ट्रीज या रैंडम फॉरेस्ट देखा था, एक एट्रीब्यूट में एक ही डिसीजन हो रहा था, एक based on one attribute. In gradient boosted trees, you can make a decision based on multiple attributes. ठीक है? And these are some of the good decision tree algorithms: random forests, extremely random trees, as well as gradient boosted trees in practice for many industrial applications. ठीक है? So any questions? So I think that brings us to the end of trees. Any questions? All right. So I think that would conclude our discussion on classification, because I do not intend to cover additional classification techniques in this course. So additional techniques, you can find them in other courses like machine learning, for example. Uh, so sometimes decision trees are not covered in machine learning. So इसलिए मैंने इधर uh, discuss किया है in data mining. And as I said, decision trees, especially these random forests and these trees, they are quite accurate as well as popular in the industry. So as a data miner, you should know what these trees are and how to use them. ठीक है? Okay, so now let's move on to the next major task, which is clustering or cluster analysis. ठीक है? So this would be a new chapter from your textbook. I think it's chapter 10 from the book by hand. All right. So I'll start with these slides and then we'll move on to the notes. So what exactly is a cluster? So it's basically a collection of observations, collection of objects, collection of data points, uh, but it has to have some conditions. Otherwise, you can have random collection of objects as well. So that is not really a cluster. So a cluster is a collection of objects with some conditions. So within a cluster, the objects or the observations are similar or strongly related. And between clusters, if you have two clusters, the objects in one cluster would be dissimilar from the objects in another cluster. Of course, this statement is the qualitative definition or understanding of clustering. We will have to quantify this precisely to actually find clusters. Mhm. So, in other words, clustering given a data set, which is you can say, as we know, data set consists of attributes, which is columns, and then you have rows, which are observations of those attributes, or rows and columns. So you are actually grouping the rows because those are our observations. Those are our uh, tuples, you can say from a database sense. Those are our uh, observations from a machine learning perspective. We are trying to group those and put them together if they are similar and put them in separate. So all similar objects would be in one group. The objects in another group would also be similar, but they would be dissimilar from the objects in the first group. And of course, the number of groups that you formed is also, uh, there could be many, of course, more than one, but there could be a large number of groups as well. So clustering is different from segmentation. So you probably have heard about the word data segmentation. Data segmentation is very simple. So let's say if you have any data set, data segmentation simply means that you're partitioning the data using some condition, usually an attribute value. So for example, so let's say as we said, we had discussed a data set that had gender as an attribute. So gender has two possible values, right? M and F. If you split the data such that all males fall in one group and all females fall in the other group, this is not generally not called clustering. This is simply called segmentation. Okay. Mm. So generally clustering would be much more involved than this. We will like to group the objects based on all the attribute information, not just one attribute information. And as we saw in the definition, we are looking at attributes that are similar and we are looking at attributes that are dissimilar. So we have to quantify similarity. So that's a major part of clustering, which we will discuss shortly. So clustering has a lot of application. Actually, clustering is one of the most widely used application of, you can say, data science in all domains, from sciences to the social sciences to the humanities. Because one of the reasons for this is you don't need labeled data set for it. You need to have a data set with observations recorded for various attributes, and then you can group them or you can apply the algorithm to group them. Okay? And also within data science, clustering, as we saw in when we were discussing data preprocessing, is also used in other applications, other tasks as well. So you can use clustering for data reduction. You can use, for example, you can use stratified or cluster-based sampling, for example, or you can use clustering for discretization as well. You can So you can also use clustering to create various groups and then try to understand those groups, which is like hypothesis testing. And you can also use it down the road for prediction as well. Okay. So the applications arise in all domains, from the sciences to the social sciences to the humanities. So there are some examples given here from bioinformatics. So from GIS, Geographic Information System, you can basically characterize based on images of satellite images. You can find groups of, uh, for example, you can define villages, for example, or cities, or the borders of cities. So in the industry, you can use it in various areas. Marketing is one example. Find segments or groups of people who have similar buying behaviors. Okay, so all of these examples actually are from the sciences, but as I said, you can also use it for political science, social science, economics, uh, even humanities. So where you're trying to understand, for example, anthropology, human culture, human behavior, and so on. So, what are the basic steps? Obviously, you will have some data set, and if you don't have a data set, then you will start with feature selection and collecting the data. Or if you already have a data set and a feature, then you might want to restrict yourself to a reduced feature set. So basically, dimensionality reduction. We talked about feature selection, feature extraction in data preprocessing. The next most important thing is you need to have a proximity measure. So this proximity measure is known by other names as well. You can call it similarity function or dissimilarity function or even sometimes distance function. But proximity measure is a general, more general terminology, includes similarity, dissimilarity. Sometimes proximity के बजाय हम इसको relatedness measure भी use कर लेते हैं. So there are different names used here. So what is the idea behind this function? This function should be able to quantify the relatedness between two observations. और इसी relatedness की basis पे हम देखेंगे whether two objects should belong to one cluster or not. So finally, so we mentioned that uh, we have a proximity function that tells us how two objects are related. We also need to have a procedure or algorithm to decide which attributes to put in one cluster, sorry, which observations to put in one cluster and which observations should be in other clusters. So that is the clustering algorithm itself. So these are some of the things that we'll be talking about in more detail in this section of the course. So how can we assess the quality of a cluster? Of course, we will be discussing evaluation of clusters later on as well, but very briefly here. So intuitively, we like to have clusters that in which within one cluster, all objects are highly similar and between clusters, objects are dissimilar. Okay? So high intra-class similarity and low inter-class similarity or high inter-class dissimilarity. Okay, so all of the factors that we talked about earlier can impact the quality, and we will have to assess it quantitatively, which we'll discuss during this course later on. So I will skip this slide. So I think I will skip this as well. So there are actually various ways of categorizing clustering algorithms. So there are various ways of characterizing clustering algorithms. We'll discuss that I think in the next lecture. So today we will start with proximity function. So remember, so proximity function, dissimilarity function, or distance function is an essential requirement for clustering. Excuse me. So let me write the data set. Usually we have our data set as a vector x. Okay? So this is one observation. So vector x, this is a vector of length m. So we have basically m features that describe each observation or object. Okay? If you put all these so let's say if you have n observations, so you can put all in a matrix. So what we have is a data matrix, right? So data matrix would then be of size n by n. So this would be our input data to the clustering algorithm. We have n observations, n objects. Each observation is described by m attributes. Okay? And our goal would be in general to group these n objects into some k number of clusters. So k generally much less than n is the number of clusters. So we like to group these n observations into k clusters. Okay? With the conditions, of course, that within a cluster, observations or objects are similar, and between clusters they are dissimilar. So coming back to our dissimilarity function. So let me say it is a. Let me first start with a distance function. So distance function is used in statistics, and let me call this d. So distance function between two observations xi and xj. So distance function is a specific type of dissimilarity function. Remember, it quantifies dissimilarity. Distance is a notion of dissimilarity. Okay? So if you have two observations x1 and x2, the distance function will give you a value which is greater than or equal to 0. Okay? 0 means that they are not dissimilar. If they are greater than 0, that it is dissimilar. And it may or may not be bounded on the upper side. So higher value is key. Infinity भी हो सकती है, but through normalization you might bound it. Maybe maximum distance is, let's say, 1 or 10 or 50 or whatever your domain specifies. ठीक है? So if you talk about distance functions, and if you think that objects, so we have each object described continuous or numeric attributes. So for attributes, right? If all attributes are numeric, so distance function is basically the most common form is your Euclidean distance and its variant. Okay? So this is the most popular uh, distance function if all attributes are described by continuous values. Uh, and this basically represents the straight line distance between those two observations if they are plotted in an m-dimensional space. So, so Euclidean distance, straight line distance, if these two observations are plotted in m-dimensional space. So if this 2D space, then this is a straight line distance in a plane. 3D may straight line distance is in space. ठीक है? ये कहीं ऊपर से आ गया, ठीक है सही। So I think you all know the formula for Euclidean distance. If you write it in terms of vectors, so remember x and xi, xj are vectors. ठीक है? So the Euclidean distance is basically sqrt. ठीक है? Of okay, so xi minus xj. This is the vector difference. ठीक है? And so vector is usually a column. इसको मैं transpose कर दूंगा. And then I multiply it again with xi minus xj. ठीक है? So in other words, the square of the sum of the square of the elements, and then they take the square root. If you want to write it in terms of uh, summation, so ये बनेगा. Vector form में x is a vector, xi is a vector, xj is vector. Vector difference लिया, ये भी एक vector आ जाएगा. Vector जब भी हम लिखते हैं without any qualification, it means that it is a column vector. इस column को मैंने row कर दिया transpose से. दूसरा भी वेक्टर है, तो रो कॉलम जब मल्टीप्लाई करेगा तो स्केलर आ जाएगा. ईच एलिमेंट ऑफ द वन वुड मल्टीप्लाई विद द अदर. तो एक स्केलर वैल्यू आ जाएगी, उस स्केलर वैल्यू को फिर आप अंडर रूट ले लेंगे. ठीक है? सो दिस इज द एस क्यू, दिस इज द यूक्लिडियन डिस्टेंस बिटवीन टू पॉइंट्स. और इसी का मैनहट्टन डिस्टेंस भी इस तरह ही आएगा आपके पास, विच इज सिमिलर. ठीक है? मैनहट्टन डिस्टेंस बेसिकली एक्स आई एक्स जे इज बेसिकली नाउ द एब्सोल्यूट. ठीक है? सो बेसिकली तो यू हैव टू एक्चुअली सम ईच एलिमेंट. ये मैं समेशन के फॉर्म में लिख लेता हूँ. सम ओवर k. k आर द नंबर ऑफ फीचर्स, सो k इज इक्वल 1 to रेज टू पावर m. ठीक है? दिस वुड बी x I k माइनस x j k एब्सोल्यूट. ठीक है? सो दिस वर्टिकल बार मीन्स दैट एब्सोल्यूट. जो डिफरेंस लेंगे नेगेटिव है तो उसको हम पॉजिटिव कर देंगे. तो जो भी पेयर वाइज डिफरेंस लेंगे एंड सम इट अप. बाय द वे यूक्लिडियन डिस्टेंस का फॉर्मूला क्या होगा, इसी तरह फॉर्मूला बनेगा. ये आप स्क्वायर होगा इसके बाद, इट वोंट बी ए एब्सोल्यूट उसके ऊपर स्क्वायर कर रहे होंगे. जो ऊपर फॉर्मूला वेक्टर नोटेशन में लिखा है, यहाँ एलिमेंट वाइज लिखा है. ठीक है? और आई विल जस्ट राइट द लास्ट एंड देन वी विल आई थिंक स्टॉप फॉर द क्विज. मिनकॉस्की, दिस इज द जनरल फॉर्म. सो इसका इसका डी बेसिकली इस तरह है. अगेन आई राइट इट इन टर्म्स ऑफ समेशन. k is equal to 1 to m. So we will have ठीक है. So x I k minus x j k raised to power of some p. ठीक है? And then finally raised to power the root of p. ठीक है? So this is a general formula Minkowski distance. अब p को 2 कर देंगे तो आपके पास यूक्लिडियन डिस्टेंस आ जाएगा. p को 1 कर देंगे तो आपके पास यूक्लिडियन मैनहट्टन डिस्टेंस आ जाएगा. So I will stop here and we will continue from here and discuss the remaining similarity functions, and then we will move on to our clustering algorithms itself in the next lecture. Okay. So are there any questions? So we have a quiz now. Any questions? Sure. So I think you can then prepare for the quiz. So we have our fifth quiz now, 10 to 12 minutes long.